So starting today, we're going to talk about the charging system, and I've got in my hand here the heart and soul of a charging system, which is an alternator. And this is a DC generator. Sorry, it's an AC generator, but we convert it to DC. So a generator is any device that makes electricity. This one makes alternating current. We convert it to DC with a series of diodes. Everything in a car has to run on DC because our storage batteries are all DC. So we use an alternator to make AC and convert it to DC. So everything on the car runs on DC with some small exceptions. So the components of it, first we have a battery. That's our power source, PWR, my abbreviation. It's our power source for the alternator to get it initially charging. Secondly, and I put there alternator field. So the magnetic field inside an alternator is energized by the automobile's lead acid battery. So then we have an alternator, which is an AC generator. It's going to make AC current. Again, we convert it to DC with a series of diodes. We'll talk about that. We have some sort of a pulley, and we have some OAP and OAD alternator pulleys. These are basically decoupling pulleys that we're using on modern cars to prevent vibration and to reduce drag and things. And we can look at that on that YouTube video to learn what they are. But we have alternators with types of alternator pulleys. We have a voltage regulator, and the voltage regulator is used in the system to control voltage and current output, like it says there. So it is the voltage regulator's job to decide how much voltage the alternator is going to make, how much current it's going to produce at any given time. An alternator is an on-demand charging device, meaning it makes power to meet demand. It is not just charging at max output all the time. It's only charging at what is it's being asked to give, if you will. And on modern cars, the powertrain control module, the engine computer, is involved in deciding how that alternator is going to charge, how much current voltage it's going to charge at. So let's continue here. We also have a voltmeter on the dash that's going to measure system voltage. Old school cars in the 60s had ammeters on the dash. We now use voltmeters on the dash, or we'll just have a battery icon, a red battery icon, which is telling you that the battery is not being charged. It is not telling you that the battery is necessarily bad. It does indicate that the battery may drain because it's not being charged. But when that red battery icon comes on, that's because you have an alternator that's not charging the system anymore. And one other thing, sorry, the camera's just a little bit low. We've got computer controls controlling the voltage regulator. So the PCM, which is the engine computer or powertrain control module for OBD2 terminology, is controlling the voltage regulator's output. And years ago, the computer wasn't doing anything to the charging system. Now it's actually controlling the voltage regulator. So we can do things like we can actually shut the voltage regulator down and freewheel the alternator so that we can put more power to accelerating the engine when we're trying to get power on a modern vehicle with a smaller engine that saves weight to reduce gas, fuel consumption, etc. So how is an alternator constructed? Well, first it's got a rotor. And a rotor is a rotating electromagnet. So here's a rotor that I'm spinning right here. There's the rotor. It's a rotating electromagnet. It says that that electromagnet is called the field, and you can look inside in the center between these pole shoes. You can see a spool of solid copper wire, approximately 16 gauge, plastic coated, that's wrapped around there, and that's what makes essentially the field or the magnetic field. So like it says, you got a spool of plastic insulated 16 gauge wire. There are north and south poles, so these are north and south poles to intensify the magnetic field and kind of set the magnetic field up. And it spins in a housing with a bearing back here. You can't see the bearing on this one. And on the other end, it's supported at the front by a larger bearing. And the reason for the larger bearing is that that's where all the tension from the belt is pulling on. So that larger bearing is right behind this pulley in here. Okay, at the front of the alternator. Next, we have what's called a stator. And the stator is a group of 3 or 4 pairs of wires, as you can see joined here. 3 or 4 pairs of wires, and this one's actually got 3 pairs, and all these wires are joined at the other end, and I'm not sure on this stator if I can see where they're joined at the other end. I'm looking, and I don't see it, but you can see 1 pair, 2nd pair, a 3rd pair, sorry, up where you can see 3 pairs, and they're joined at the other end. So it's 3 separate windings of 16 gauge wire joined. Opposite ends connect to the diodes, and this creates 3-phase AC diode rectified output. So when we say 3-phase, there's actually 3 different loops of wire that are producing an AC current, alternating current. And we use diodes to rectify or change the AC into DC and give us diode rectified output is DC. Okay, so we're going to turn this, there's our 0 set line, this positive and negative voltage flowing in one loop, another one, and finally another one. We're going to turn it into all DC, so it's all positive AC voltage swings. Okay, so we also have brushes inside the alternator that are going to contact what we call the slip rings of the rotor. So here you can see the slip rings right here, these 2 round copper contacts, and there's the brushes there. These let me set this down. These spring-loaded, they're sintered bronze, which is like a powdered metal kind of construction that rides on right on this guy. So this would go inside there and ride on that slip ring with those brushes and bring a battery positive, battery negative, but actually it's a voltage from the battery that's controlled by the voltage regulator. So the voltage regulator decides how much current this rotor gets, and so how strong a magnetic field it's going to make, and consequently how much output it's going to make. There are bearings, and you can see this sealed roller bearing that's inside this housing half to support one end of that rotor, and then the other one's at the other end. And then a modern alternator has some fan blades attached to the rotor on the inside of the case to blow air through all these slots in the case here for cooling. Also, it reduces weight to have it with so many openings like that. Okay, so we've got a rotor, a stator, we've got a housing, I think it's going to come up in the next slide, brushes, bearings, and a fan. Okay, so I didn't put the housing down there and should get that to focus. There it goes. So how does an alternator function? How does the thing actually make power? Well, we're going to make power by what's called electromagnetic induction. And I like to be able to take complicated words and break them down so we can understand them. So I'll grab my pointer here. So a magnet, all right, can be made with an electron flow. So we can flow current through a coil of wire and make an electromagnet, as opposed to a permanent magnet. You know those little cool permanent magnets your mom gave you to get you out of the kitchen for a couple hours when you were a little kid. You pushed them around the backyard, or you turned them around and they attracted to each other. So we're going to make an electromagnet. We're going to cause induction. Induction means to put into. So we use an electromagnet to put a current flow into an adjacent conductor. So current flowing in the rotor from the battery, regulated by the voltage regulator, is going to create a magnetic field. The stronger the magnetic field, the more output the alternator makes. That spinning magnetic field is going to pass a stationary conductor, or several stationary conductors, which is what the stator is, causing current flow in the conductor. Okay, so basically if I spin this rotor, and I've got stationary conductors around the outside called the stator, and again this guy fits right inside there and it spins, I'm going to get current induced or put into these windings. And depending on the amount of windings and the size of the wire, I'm going to get a current boost. I'm going to make, get a voltage boost and a current boost. So what you have in this picture, and I really like this picture even though it's a little bit, the focus isn't fantastic. Unfortunately, this guy doesn't focus so well on it. I don't know if it'll do any better if I come closer. I'll go further. Yeah, it's really not. If I get out of the way, it does a little bit better. Okay, so let's talk about this. So let's find something that we can understand. Well, there's the battery. That's our universal DC battery ground symbol. So this is our positive side, negative side. So on the positive side, and this dashed line all the way around here is the alternator itself. So we got a battery, and outside this, in the instrument cluster, we have a warning lamp, which would be our picture of the little battery. We've got an ignition switch that's kind of controlling where power goes, etc. So everything inside this dashed line is the alternator. So let's try and figure out things. So first, let's look down here. Here's the rotor with its coil of wire. That's what's in the middle of this guy right here. So this is the rotor in the middle inside here. Right inside there, you can see those coils of 16 gauge plastic coated wire. Sorry, the glare is a little tough. And then here's the slip rings on the rotor. Those are the brushes. And of course, this isn't to proportion because the brushes aren't nearly as large as the actual coil of wire. Then here's the 3 stator windings joined at one end. And the other end of each stator winding is going to a pair of diodes. So you have 2 pairs here, here, here. And then you've got some more here. The whole job, as this rotor spins and induces current into these 3 windings, it goes to these diodes, and the diodes basically, like a little maze, cause everything to flow in one direction, okay, back to the battery. So we're taking the AC and we're turning it into DC. That's a little capacitor, a little a little electrical capacitor. And then all of this is our voltage regulator, which is a little more complicated circuitry, but this voltage regulator is going to control how much current goes back to the battery. So current's coming out of here, going up here, and going back into the battery. So the way this is controlling this current output is by controlling what goes into the rotor. Okay, so all this stuff here is the voltage regulator controlling voltage and current to the rotor. The output of the stator goes into the diodes, turns it into DC, and charges the battery. So these are the universal symbol for diodes. That's a transistor, 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 a resistor, 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 coil, 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 ground symbol, capacitor, ground symbol, diode, 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 diode. Okay, so you get an idea of what those things are. Let's continue on here. So how does the alternator function? So what we call diode rectification. So the diodes are going to rectify or channel the current flow from AC to DC. We use 3-phase AC output and we convert it to DC. Let me show you a pair of diodes. So here is a pair of diodes, a group of diodes. There's 1, 2, 3, 4 diodes there. 1, 2, 3, 4. So there's 4 positive and 4 negative diodes. The brushes, you can't see them, they're not in there right now, but they would be down in here. This is the voltage regulator right here. This is a heat sink, so this guy right here is the voltage regulator on the back side. This guy's controlling what goes to the brushes. These guys here, these 4 negative, 4 positive diodes, are controlling the output here that goes to the battery. So you have there's another group of 8 diodes. 6 diodes, 3 positive, 3 negative diodes there, and their output going to the battery. Here's a Subaru that wasn't charging right. If you can look really carefully, see if you can see here. I get the camera way up there. It's a little hard to tell, but these are burned. These diodes, some of them are burned right here. So this was a 95 Subaru Legacy. Had burned out diodes. It wasn't charging properly. You can actually replace these, but typically we just replace the whole alternator with a rebuilt unit. So here's our 3-phase diode rectified output. And all this is showing is, in this scenario here, where current is flowing this way through these 2 coils, you can see how current is trying to go this way and how the dashed diodes are blocking the current. Sorry, the dashed diodes are not in the circuit. This one's blocking the current. This one's letting current go through to the battery. When we switch direction, then current can go through like this, go through that diode like this, go up like this, and go back to the battery. Here's scenario B, where the current's going this way or the current's going this way, and we use these diodes to get it to go to the positive battery terminal. And then finally this way and this way. So these are our three phases, and where the current's flowing in one direction and in the other direction. Okay, so as the North Pole approaches a diode wind or a stator winding, current flows in one direction. As it goes away, it flows in the opposite direction. So that gives you a little idea of how we convert the three phases of alternating current into DC to charge the battery. Let's go further. So now that we've looked at the components, let me see if I can get this thing to focus here. Sorry, why it does that sometimes, I don't know. Oh, it's not going to do it. So let me try and get it focused. All right, there I got it focused. So, oh, and it goes out of focus. I'll try one more time. So it seems like as long as I stay out of the picture, it seems to focus. Of course, now it's not focusing. So I'm going to try this one more time. There it focuses, and if I bring it back, hopefully, no, there it goes. Okay, so let's try it. So how do we diagnose charging system? First, we're going to check our battery cables and condition to make sure we're full of electrolyte, our cables are clean and tight. We'll look at the date code in the battery, make sure it's not close to 7 years old, and it has a resting voltage of around 12.6 volts. So we also want to measure at the positive negative terminal while the engine's running, make sure we have 13.5 to 14.5 volts running voltage. Okay, that usually tells us that if we have 13.5 to 14.5 volts, we know that the alternator appears to be charging, although that's not a definitive test. Then we want to make sure that we have the correct number of amps being provided by or being produced by the alternator at 2000 RPM while maintaining a minimum of 12.6 volts. So when we do an alternator output test, we're going to draw suck power or load the alternator and see if we can get the correct number of amps at 2000 RPM while maintaining 12.6 volts. Most modern cars will not allow you to do an alternator output test anymore, but they have a specification. They say start the car, run it at this RPM, turn on the high beam headlights, turn on the AC system, and then measure the current draw out of the current flow out of the alternator or at the battery. And we can do that with that 600 amp inductive clamp that we used in conjunction with our voltmeter yesterday when we were doing starting system testing. We also want to make sure there's no battery spills, no battery acid spills, which would indicate an alternator that was overcharging because the voltage regulator was malfunctioning. We also want to note if the headlights are normal brightness. So overly bright headlights are indicator of a voltage regulator that's overcharging the battery. Further, we're going to do an alternator output test. And this is the test that tells us, can the alternator give us our rated amperage output at 2000 RPM and maintain a voltage of 12.6 volts. And there is a thing called a full field alternator output test that's not really done anymore, but this gave us a way of bypassing the voltage regulator and forcing the alternator to produce maximum output. And I do have a car here that we can still do that on, and we don't do it on modern cars with computers involved, but it was a way of us deciding, is the alternator working correctly or is the voltage regulator malfunctioning? So that's called a full field alternator output test or regulator bypass test. And then we can test the rotor and the stator for opens and grounds, and we'll do that. We'll take an ohm meter and just check the rotor. We'll check the coil in the rotor to make sure it's not open, that it has a couple of ohms of resistance, something like 1 or 2 ohms, and it's not grounded to the shaft of the alternator. Okay. So just a little bit about repair and replacement. Most of the time, and again, sorry for the lack of focus, but most of the time on modern cars, we are, come on dude, focus. Most of the time we are replacing with like a rebuilt alternator. But the brushes are wearable, replaceable parts. The bearings are replaceable and repairable parts. A diode assembly can be replaced, although we're not doing it on a modern car, a couple $100 alternator max. But on something very large, like a piece of farm equipment or a big truck, we may replace the diodes, brushes, and bearings and the voltage regulator to rebuild that alternator because it might be too expensive or difficult to get a new assembly, but it depends. But the brushes, the bearings, the diodes, and the voltage regulator can be replaced, although not really commonly done anymore. But when they're rebuilt at the factory, they're going to sand the slip rings where the brushes contact. They're going to replace the brushes. They're going to put new bearings in it. They'll probably check the stator and the rotor for opens or shorts to ground. The voltage regulator, whether they replace it or just check it out, I honestly don't know, is what a production rebuilder does. But those are all replaceable parts. Okay. And I mentioned just sanding the slip rings so that you get a good contact where the brushes are hitting those slip ring contacts. So what we're going to do now is we're going to do some testing. So I'll pause the video here or stop the video here, and then I'll make a second video that shows us doing some testing of the rotor, of the battery, of the charging system, etc. So we'll go to that now. Thanks for your attention, by the way. All right, this morning we've got an opportunity to look at charging system testing. And what I would like to do is start with this vehicle behind me with the Chevy Silverado, and we'll go ahead and take the camera and hopefully not get you too dizzy. And we'll just look at the specs on it. So this is a 2007 model year, and it is a 4.8 liter V8. So it is a V8, but it's a 4.8. And if we look over here at the VIN for just a moment, you should be able to see, there's the VIN there. See if I can get close enough so you can see it. Yeah, and it says a C1, so C is that fifth digit's a C, which means it's a two-wheel drive, and then the one after it means that it's a half-ton. So this is a 07 4.8 liter half-ton two-wheel drive Silverado. So what we're going to be doing is we're going to be testing the charging system. There's the alternator there, and it's driven by a serpentine belt. And you remember that we can take a tool and look to see if we have if the serpentine belt is worn, so we can get down in there and look at the grooves, and we can take our little tool to measure that. And I'll show you that in just a moment here. So I got my little tool here, and I'm giving some light down there, and I can put this tool in there, and then what I'm going to do is try and feel across there, and I don't know how well you're going to be able to see it, but I'll do my best here to look across that thing and see if it's submerged or if it's proud. It feels like it's a little proud, which means that's good. That means it's not so worn. But I also see some cracks down here on the belt, which some cracks are considered to be okay. The belt is pretty dry, and this is maybe a better spot for me to test it because I can get the camera on there. And it's sitting in there. Sorry, I'm having trouble doing this with. No, it's down below the belt. So this belt is worn out, and we should replace that, because when you look across this thing, if it's even with the tops of the ridges, then it's worn out. This thing should be sitting up a little bit. So we think we're going to have to replace that. So I'm going to put the camera up here. Again, I apologize, it's so jerky, etc. And what I'm going to do is, there's my battery over there, and I'm going to try and carefully wheel my screen and recording stuff over here so you can see the battery there. And when you look at the battery, it's a little hard to see from where you are, but there's the positive and negative terminal. Come over here, get a better look at it. Here's the positive terminal there. There's the negative terminal there. It's a maintenance free, so we can't check the water. I don't see a date code handy to know how old it is, but what we are going to do, and actually maybe I could put this up here and look across it like that. I'm going to take the voltmeter, and the first thing we're going to do is what we call charging system voltage. So we're going to look at the charging system voltage on this guy, And I know you're just fascinated by my professional recording skills. So I'm going red to positive, black to negative across the battery. So there's my leads. I just use the alligator clips to get onto the negative there, sorry, the positive there, and to the negative there. Now what I'm going to do is I'm going to go ahead and start the car, and you will see the charging system voltage. We expect to see 13.5 to 14.5 volts. And right now we're resting at, look at this, we got rat poop right here. So obviously there's been rats living under this thing. But we're showing this thing at 12.53 volts. So let me go start it and kind of wedge it in here so you can see the screen. I will start it and we will see what we get. So here we go. I'm starting the car up right now. So you can see on the screen that the charging system voltage is 14.77, 14.78 volts. So it appears that this thing is charging. And you probably can't hear it very well, but we are getting a little whining out of this alternator, either because of the, sounds like the buzzing out of the alternator, which is fairly normal. Sometimes this idler pulley makes a little noise. The belt's a little dry, it does need a belt. It is interesting to note that this 07 uses 2 electric fans and not a belt-driven fan, which is kind of interesting. And yes, it needs a pressure wash and needs to be cleaned up, and we'll be doing some of that. So our charging system voltage is sitting around 14.8 volts. So it looks like it's charging. But now what we're going to do is we're going to go ahead and do a alternator output test. And we can do this a couple of different ways. So let me go ahead and hook up our machine. I'm going to go ahead and hook it up red to positive, which is a little challenging. Oh, there we go. I got it in there. And black to negative, if I can get it down in there. I think I can. There we go. Red to positive, black to negative. Then over here on the machine, if I can pull this off and not make you too dizzy. Over here on the machine, I've got the amps connector off. And I can zero the ammeter. I had it zeroed, but I'm just kind of showing you I can adjust it down to 0. And then the most accurate way to do an alternator output test, as I pull the machine over, is come over here to the car and get this inductive lead around the battery or the alternator output lead. I can put it around the battery cable over there at the battery. But if I put it around this guy here, I'll get the most accurate output. Now, what we're going to do is I'm going to go ahead and set the voltmeter and its inductive amp aside. And when I start the vehicle, we should see that charging system voltage on the screen. This machine is not as accurate as that digital volt-ohm meter, so just be prepared for it to be not exactly the same. Let me turn it like this and put this here so we can see it like this. And so what's going to happen is I'm going to put a pedal depressor to the floor and onto the gas pedal, and I'm going to get it up to 2,000 RPM. Then I'm going to come out here. This is going to be reading about 14.4 volts. I'm going to turn this guy up, which is a load. This loads the alternator. This is going to suck power and expend it on what's called a carbon pile. A lot of modern cars won't let this test work. I believe this '07 will. It's old enough. We're going to read the max amperage and not let the voltage drop below 12.6 volts at 2000 RPM. So once again, I put the pedal depressor on the throttle, hold it up at about 2000 RPM. I'm going to come out here, load this, get the max amperage at 12.6 volts. We are stressing the alternator. So let me get that set up. So here I am back with the pedal depressor that you can see. I'm going to go ahead and put onto the throttle. When the car starts and it's at 2000 RPM, it'll be loud, so I'll just be pointing to here and here when I crank this up. So you're going to see in here, I have the pedal depressor on, and the tach is up around 2000 RPM there. Should be able to see it. Here's my pedal depressor. When I release it, I just push there. So I'm going to come back out here. We can see that this thing's charging at 14.5 volts, and it's at about 40 amps already, and the reason is because we got the headlights back on again. I'm going to go ahead and crank this up and get the amperage as high as I can, not letting it go below 12 volts, right about there, about 105 amps, 107 amps at 12 volts, maybe 109. I'm going to let it off there. Okay, so you can see that thing was running right about 109 amps at 14.4 volts on this load tester. Modern cars aren't going to let you load test it with this. Modern cars are going to shut down the alternator. They're going to shut down the alternator, and because the computer sees all this current going out of the alternator, it says, "No, I'm not doing it." Shuts the voltage regulator down, doesn't let the alternator charge. So we have to use, in that case, we have to use that voltmeter with the inductive lead that we have here. We've got to use something like this and follow ProDemand telling us, okay, you're going to have to hook this guy up. You turn on the headlights, run it at 2000, turn on the AC, and decide where it's at. Okay, so that's charging system voltage. That's doing a load test. And now what we're going to do is, we've also checked the belt and decide we need to replace it. Now what we're going to do is show you how to check a alternator rotor for shorts and grounds, shorts to ground, and for opens, and see what the resistance is, as well as the stator. Let's do that. Okay, so what we're going to do now is we're going to show you how to test some alternator components. I'm going to take my leads, my banana connector. I'm going to take off that alligator clip. I'm going to put on a probe like this. First thing I'm going to do is look at this rotor for shorts to ground and opens, and resistance. I'm going to put the meter to ohms, so you can see the Greek omega symbol and auto zeros. And I can put this down. It's going to read OL because that means out of limits. Let me drop the camera a little bit. If I touch these together, you're going to see that the meter goes to about 0, or I'm getting close to, sorry, I can hold this tight. So about, okay, so that's a little bit janky. Should be closer to 0. Let's see if we can get it closer to 0. So there we go. And for whatever reason, this meter is not zeroing. So let me get another meter. Okay, I don't know if the battery was low or whatever, but now it's zeroing. So it's going down really close to 0, which is 3/10 or something. What I'm going to do is I'm going to check this first for continuity. So I'm going to go on this rotor. I'm going to touch to these two sides of the slip ring, and if I can scratch them and get a good contact, you can see, trying to get this thing to stabilize. I'm going to see if I can get another meter that'll stay. All right, so this one's obviously zeroing much better. You can see it's reading OL. When I touch it together, it goes to like 1/10 of an ohm. So I'm assuming on this other meter that the battery may be going bad. So I'm going to go ahead and swap this lead out here, and I'm going to touch the rotor across the slip rings like this, slip ring to slip ring, and I am reading about 3.1 ohms, so about 3 ohms of resistance in that coil, and you can tell that means It has continuity. It's not broken. It's not reading OL. And about 3 ohms is normal for the amount of wire that's in there. Now I'm going to check this rotor for a short to ground. So I'm checking from either slip ring to the case, and I should go to OL, or from either slip ring to the shaft, and I get OL. So there's no ground. So this thing is it's got continuity through the coil, about 3 ohms of resistance. There's no ground here. So we can say that this rotor is good because there's continuity in there. It's about 3 ohms of resistance. There's no shorts to ground. We're going to look at the stator now. So same thing with the stator. We're going to go across the leads. We're going to go to these two, and we get about 3/10 of an ohm. We go to these, get about 3/10 of an ohm. We go to these, we get about 3/10 of an ohm. So 2/10, 3/10. So there's 3/10 of ohm in these wires, and it's a lot less than this coil here because there's just a lot less wire. Finally, we're going to touch from one of these leads to the case, and we should get OL, so it's not shorted to ground. So we've checked both the stator and the rotor for shorts to ground and, sorry, I interrupted myself, and continuity. Finally, we're going to go ahead and test these diodes and show you how to test the diodes. So what we do is we put this on the ohm setting here. See if I can get it so the glare is not so bad. And what we're going to do is we're going to push this, and we see a tone symbol. Push it one more time, and we see a diode symbol up there in the corner. So now we can check this for diode resistance. What it does a voltage drop on this. So I'm going to touch this from this diode to the plate. Let me do that again. From this diode here to the plate down here, and then I reverse the leads. And what I should get about a 1/2 volt in one direction, and when I reverse the leads and go the opposite way, I should get OL. Now, part of the problem is I got to make sure I'm insulated here. So I go on this guy here, right there, and I get about a 1/2 volt, and then I swap my leads here and go there, and I get OL. That one's reading correctly. So this one I get OL, this one I get, let me get the other one down there. I get this OL on this one. Sorry. Now if I swap the leads, should get about a 1/2 volt, yep. Should get about a 1/2 volt, yep. And on these, if I touch here, OL, 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 and then if I reverse the leads, I get about a 1/2 volt, 1/2 volt, and 1/2 volt. So all these diodes are good. And again, I was just checking from that diode there to the base there, or this diode here to its base here, and then swapping the leads. All these diodes are good. There's nothing wrong with these at all. So that shows you how to not only check the rotor and the stator for shorts, etc., but also the diodes. One final thing, again, we can sand these slip rings to get them good, and we can replace the brushes if we're rebuilding it, replace the 2 end bearings, and that's what's involved in rebuilding an alternator. Okay, so that's it. There you go.